Welcome back to Chem Reactor. In today's video, we're going to discuss a very important question in organic synthesis. How many equivalents of triphosgene are required for coupling? Triphosgene is a safer alternative to phosgene gas. Let's directly get to the point. How many equivalents are needed? As I said, triphosgene is a safer alternative to phosgene. So one molecule of triphosgene breaks down to 3 molecules of phosgene. In generally, about 1/3 of equivalent of triphosgene is used in place of 1 equivalent of phosgene. But the exact amount of triphosgene required for a coupling reaction vary based on several factors like substrate type. So if you have substrates like carboxylic acid, amines or alcohols, they may react differently or may have like other substituents on it. So you may have to adjust your triphosgene requirements. Then the second, reaction conditions. Solvents, type of solvents, temperature and the catalyst can influence the reaction. So depending on the solvent and temperature, that can also vary. And then a desired product. So if you're making amides, carbonates and urea, that may require slight adjustment in your triphosgene amounts. So to have a successful reaction, always check the literature reference or optimize reaction condition for your specific reaction. To better understand triphosgene, I taken here example of isocyanate formation by triphosgene, how triphosgene generates 3 equivalents of phosgene. So here a base deprotonates this amine nucleophile, and then that adds to this triphosgene that forms this intermediate 3 and then generates 1 equivalent of phosgene. So this 1 equivalent of phosgene reacts with this amine that forms this isocyanate as a product. At the same time, here intermediate 3 gets converted to isocyanate and then again generates another equivalent of phosgene, which then reacts with this amine and that forms another isocyanate. So if you look at this overall reaction, you can see here that one triphosgene molecule reacted with 3 different amines and that form this isocyanate as a product. So for this coupling, you just need like a 1/3 equivalent of triphosgene in place of 1 equivalent of phosgene required in general coupling reactions. In summary, triphosgene is a safer alternative to phosgene gas, and then you just need a 1/3 of equivalents of triphosgene for your coupling reactions like isocyanates. I hope you enjoyed the video, and please don't forget to like the video, subscribe the channel, and don't forget to hit the bell icon button for more notifications on this. And if you have any questions or anything, just comment, make a comment in the section. Thank you.